Mm-hmm. Where his exam is? Check your Canvas homepage. All righty. All right, so I am on part one of the exam. A couple things that I will point out here. When you fill out the information on your exam, it is really important that you fill it out completely. We do not put any of these boxes that ask for information on here just because we feel like it's a good idea. We really, really need all of this information from you. If you're in my class, it's going to be a requirement before you even walk into the exam location that you need to have on your calculator, somewhere on your calculator, whether you write it on there with a Sharpie or put a sticker on there or a Post-it note or a piece of masking tape. I need your name as it appears in Canvas, and I need your student ID number. Part of the reason for this is that at the beginning of the exam, in my class, y'all are going to pass your calculators up. I would like to be able to return your calculator to you. And then also you won't be able to access your phone to look up your student ID number. So it's a good idea to have it on your calculator so you can fill out all of the information. So make sure that you fill out everything, like I said, and hopefully you can do this before the exam even starts, save some time. So make sure you got your name everywhere. Please print very neatly. We do rely on Gradescope to read this. And if it's very sloppy, it makes it really hard to read. So make sure. There you go. I am my own instructor and I'm in section, let's say I'm in section 7. All right. So everything has been filled out. Here we go. All right. So problem number 1 is not bad at all. Sorry. Problem number 1 is just a very straightforward, just find the integral, right? We can do this. All right, so integral of 8x cubed, add 1 over add 1. That's going to be 8x to the power 4 over 4 minus. So the 5 here is a coefficient, integral of minus 1 over x. This will be minus 5 times natural log of the absolute value of x plus 14 sine. All right, so the integral of sine is equal to negative cosine, right? So this will be minus 14 cosine of x, and then we chunk a big old plus c on that guy. So answer here is B. All right, problem number 2. We are asked here to do a definite integral. All right, so again, let's just start by integrating the polynomial. All right, the integral here, add 1 over add 1. So this will be 3x cubed over 3 minus 2x. I'm going to clean this up just a little bit. The 3's cancel. So this is x cubed minus 2x. And now we would like to evaluate from 1 to 3. Now keep in mind, this is the no calculator portion of the exam. So we need to be able to evaluate by hand. So this is going to be 3 cubed minus 2 times 3, plug in top, minus plug in bottom. So that would be 1 cubed minus 2 times 1. All right, let's see. 3 cubed is equal to 27 minus 6 gives 21. All right, minus, let's see, 1 minus 2. And here we have minus 1. And so 21 minus negative 1 becomes 22. Answer D. All right. All right, problem number 3 wants us to evaluate the integral x times the square root of 2 minus x squared dx. All right, classic u substitution problem here. I'm going to start by letting u be equal to 2 minus x squared. All right, that's a terrible minus. Let's fix that. 2 minus x squared. So that makes du equal to minus 2x dx. All right, in my problem, I do have an x dx that I'm trying to get rid of. So the minus 2 has to go to the other side. So minus 1/2 du is equal to x dx. All right, so now for that substitution, let's sub in. I will get the integral of, all right, so the 2 minus x squared becomes u, and the x dx becomes minus 1/2 du. All right, I'm just going to rewrite this as minus 1/2 times the integral of u to the power 1/2 du. And now I can actually integrate. All right, add 1 over add 1. First of all, leave the coefficient alone, right? And then for the integration, add 1 over add 1. 1/2 plus 1, so 1 over 2 plus 2 over 2 is 3 over 2. And then we divide by 3 over 2, so divide by that. Or you could automatically say this is u to the power 3/2. Instead of dividing by 3/2, multiply by 2/3. All right, the 2's cancel out, and I'm left with minus 1/3 u to the power 3/2. All right, final step, let's plug back in. When I plug back in, I get minus 1/3. Remember, u was equal to 2 minus x raised to the power 3/2. And because this was an indefinite integral, I'm going to stick a big old plus c on this guy. All right, so that makes E my answer here. All right, problem number 4 wants me to evaluate the integral from 0 to pi/2 of sine theta d theta. All right, again, let's just start by evaluating the function. The integral of sine is equal to negative cosine. So this will be negative cosine of theta, and we would like to evaluate from 0 to pi/2. All right, plug in top minus plug in bottom. I'm going to leave this negative on the outside. So I will get cosine of pi/2 minus cosine of 0. And again, if you, in case you forget, the graph of cosine looks like this. That's what the graph of cosine looks like. So at 0, it has a function value of 1. Right here at pi/2, we have a function value of 0. So this will be negative. All right, cosine evaluated at pi/2 is 0, minus cosine evaluated at 0 is 1. So this is simply equal to 1. Answer B. All right, problem number 5. So problem number 5 is a question that really deals with the definition of the integral to see if you understand that it simply is the area between the graph and the x-axis, and that we find that net. All right, so you're being provided with a graph and you're asked to find the value of the integral from -3 to 2. So I'm going to go ahead and shade between -3 and 2. I'm going to go ahead and just shade all of the area. All right, so I'm going to shade positive area. I'm going to shade in green. So there's one square and another square and another square and another square. And then together, those two make one square. And then negative area, I'm going to shade in red. So there's one square and there's one square. All right, so what I have here in total is 1, 2, 3, 4, 5. I got 5 positive, and I've got 2 negative, right? Do y'all see that? We're literally just counting squares. So this gives me a total area of 3. Answer B. Right. All right, problem number 6. wants me to compute the second derivative of t, where f of t is equal to the integral from 4 to t of the square root of sine of x dx. All right. So I'm going to start by finding the first derivative. Now, in this case, I'm going to have to use the fundamental theorem of calculus, the one that we kind of dub, because there's two fundamental theorems, right? So we dub this one the do nothing theorem. If you're finding the derivative of an integral, you really do nothing. In this case, since the integral is going from a constant to a variable, the only thing that I really need to do is just plug in that variable. So the first derivative is going to be the square root of sine of t. That's it. There's no plus c or dt or dx or any other notation. You're done, right? So we found the first derivative. So the second derivative, we're going to need to know some chain rule from Calc 1, right? So derivative of the outside, right? Derivative of a square root is 1 over 2 times the square root. So derivative of the outside is 1 over 2 times the square root, leave the inside alone, sine of t, times derivative of the inside. Derivative of sine of t is equal to cosine of t. So if you clean this up, this is just cosine of t divided by 2 times the square root of sine of t. Answer is E. All right, number 7. All right, so problem number 7 is a proper definition of the integral problem. So we are asked to find which one of the following integrals matches the limit as n goes to infinity of the sum as I goes from 1 to n of e raised to the I over n plus 2 times 1 over n. All right, so I know y'all hate these problems. They're not as bad as you think. So here's a strategy that works. The first thing that I want you to do is in this definition, well, first of all, we need to identify that this lines up with the limit as n goes to infinity of the sum I going from 1 to n of f of x sub I times delta x, right? So this piece right here, this is the delta x piece, right? And then this piece right here, this is the function evaluated at x sub I. So first, pull out the delta x, because we know some things about delta x. We know by definition that delta x is b minus a over n. And so in this problem, it is equal to 1 over n. So what this tells me is that b minus a must be equal to 1. So immediately that piece of information will allow you to at least eliminate some of the answer choices. Which of these answer choices have an A and a B that do not have a difference of 1? A, I can eliminate A, I can eliminate D. So already 2 answers have been eliminated. So for the ones that are left over, work backwards. Take the integral and write it as a definition, right? So for this problem, and we'll do the correct one last. Let's start with the wrong one just to show why they're wrong. So here's the strategy that I want you to use. So first of all, so we know for all of these that's left over that delta x is 1 over n, right? So what I need to do is find x sub I for each of them. And I'm going to remind you that x sub I is a plus I times delta x. This is just by definition. So if I find for this guy right here, I'm going to find x sub I. So a is 0 plus I times delta x. So that's just going to be I over n. So x sub I really is just I over n. So what does that make f of x sub I for this guy? Here's your function. Just plug this x sub I in. So that would make this e raised to the power I over n. And go back and check, does that match what you have in the problem over here? It does not match, right? So you can see that this is not your answer. So strike that guy out. Let's look at C next. Again, if I find the x sub I here, that's going to be A. A in this case is 1, right? So this will be 1 plus I over n. So take that and plug that into the function to give f of x sub I. So again, if we plug this x sub I in for that x, we're going to get e raised to the power 1 plus I over n plus 2. And again, you're going to see that that does not match what I have in the problem up here. So that's why this is not the answer either. So let's do the same for B. If here I find x sub I, that's going to be A, which is 0, plus I over n, right? Take this x sub I and plug it in for that x. So in other words, find what would f of x sub I be for this option. It's going to be e raised to the power I over n plus 2. And this does match what I have in the problem statement. So this is why B is my answer choice. Can I answer questions here? Real good. So I would say my approach to this problem is step 1, you can probably eliminate 1 or 2 or 3 maybe, depending on the answers, but you can eliminate some answer choices very simply by just finding out what B minus A is, by just looking at that delta X component, right? And then what you're going to do is any answers that did not get eliminated, you're essentially just working backwards to see if that matches the problem, all right? All right. Problem number 8 says that the sequence A sub n, where A sub n is equal to 2n squared minus 8n over 4n minus 2n squared, converges or diverges. Now, again, stop, pause, hesitate. Over here, you are not being asked about a series, but you are being asked about a sequence, right? So really what this problem is asking is, what is the limit as n goes to infinity of 2n squared minus 8n over 4n minus 2n squared? I'm going to rewrite this just, I like to write polynomials in order of decreasing power. So I would write this as 2n squared minus 8n over minus 2n squared plus 4n. All right. You can do L'Hopital's rule in this problem, but we know from calculus 1 that if you're finding a limit as infinity of a rational expression where the degree of the top is the same as the degree of the bottom, this limit will go to the ratio of the leading coefficients. In this case, the limit goes to 2 over negative 2. In other words, this limit is equal to 1. Answer D. This limit will converge to negative 1. All right, let's look at problem number 9. This is just a very straightforward partial fractions. We're being given the equation 10x minus 25 divided by x squared plus x minus 6. And this can be broken up into a over x minus 2 plus b over x plus 3. If we decide to do partial fractions in this way, the problem wants to know what is the value of b. So again, by cross multiplication, what we're going to get here is that 10x minus 25 will be equal to a times x plus 3 plus b times x minus 2. Now, keep in mind that we're trying to find the value for b. So what can we plug in here to eliminate a? We get to pick any value for x where we're going to fix this equation to allow us to solve for a and b. So seeing that I want to eliminate a, I'm going to plug in x is equal to negative 3. All right, if x is equal to negative 3, I'm going to get, let's see, 10 times negative 3, so negative 30 minus 25, so minus 55 is equal to A times 0 plus B times negative 5. All right, so what I get here is negative 55 is equal to minus 5. B, if I divide each side by negative 5, I get that B is equal to 11. Answer E. All right, number 10 wants us to compute the integral of 5x times e to the x dx. So here's a case where we have, this is a clean product between two different families of functions, right? So we have an algebraic term, 5x, times an exponential term, e to the x. Anytime you have a product, this is not composite. This is a product between two different families of functions. We are going to use integration by parts, right? So we need to pick a u and a dv. So for this problem, we want to declare a u and a dv. And if you forget, if you struggle with this, remember the Liat principle. The Liat principle, L-I-A-T-E, it's just an acronym for, if I read it from the top, logarithmic, inverse trig, algebraic, trig, exponential. The higher up on the list you are, the more likely you are to be u. So if you look at these two guys, we have an algebraic and we have an exponential. So we're going to let the algebraic 5x be equal to u. Another way to think of it is that it's really easy to find the integral of exponentials. So that's why you want to let them be equal to dv. All right, so e to the x, and whatever you let dv be equal to, that gets the dx, right? All right, so it follows then that du is equal to 5 times dx, and v is just equal to e to the x. All right, so our formula says that the integral of u dv is equal to u v minus the integral of v du. So let's just plug in. That will be 5x times e to the x minus the integral of e to the x times 5 dx. If you want to clean it up first, you can. You don't have to. You can definitely skip this step. I'll go ahead and show that I'm just factoring out the 5. And then I can go ahead and integrate. So this will be 5x times e to the x minus 5 times e to the x plus c. So the answer that matches here is answer B. All right, problem number 11. We're asked to find the Taylor expansion for f of x equals sine of x about a equals pi halves. All right, so in order to do this, I'm going to first have to find some derivatives. So I'm going to start with, all right, so f of x is equal to sine of x. I'm going to have to write kind of tiny here. All right, so the first derivative, I'm going to be finding a few derivatives here. Third derivative, fourth derivative. Let's see if that's enough. That may be enough. All right, so if f of x is equal to sine of x, the derivative of sine of x is equal to cosine of x. Derivative of cosine of x is negative sine of x, negative cosine of x, sine of x. And now we see that this does loop, so you can make that list as long as you want, but it is going to loop. All right, we want to evaluate each one of these at pi halves. So f evaluated at pi halves. Again, in case you forget, I'm going to draw them up here for you. Here's a graph of, this is cosine of x, right? So at pi halves, it's equal to 0. And sine of x looks like this. This is sine of x. So at pi halves, it is equal to 1. Right? maybe this is confusing. Maybe I should write here. This is pi halves, and it has a function value of 0, right? All right. All right, so I'm going to have sine of pi over 2 cosine of pi over 2 we said was equal to 0. Sine was equal to 1. Second derivative, pi over 2. So that would be negative sine of pi over 2 is equal to, again, sine of pi over 2 is 1. So this will be negative 1. The third derivative at pi over 2, so negative cosine of pi over 2 is equal to 0. The fourth derivative at pi over 2, so that would be sine pi over 2 is equal to 1. So this list definitely is long enough for me to see the pattern. I get a 1, 0, negative 1, 0, 1, 0, negative 1, 0. All right, so now we need to plug in, and remember our formula for Taylor says f of x is equal to f of a plus f prime of a times x minus a to the power 1 over 1 factorial plus the second derivative evaluated at a times x minus a squared over 2 factorial, and so on. There's my formula. So let's plug in. So f of x in this case will be equal to, so f evaluated at pi halves is equal to 1 plus f prime of a. So the first derivative at pi halves was 0 times x minus pi halves to the power 1 over 1 factorial plus second derivative at pi halves will be negative 1 x minus pi halves squared over 2 factorial plus, again, 0 x minus pi halves cubed over 3 factorial, and so on, right? We can just keep going. So what does this become? If I get rid of all of these 0 terms, I'm going to end up with 1 minus x minus pi halves squared over 2 factorial plus x minus pi halves to the power 4 over 4 factorial minus x minus pi halves to the power 6 over 6 factorial, and so on. So the answer that matches for me over here is answer A. All right. Any questions or concerns? Good. All right. Number 12 says, which of the following statements is or are correct? All right. So I'm given 3 series and I'm being told something about their convergence or divergence. We want to go ahead and see if that is correct. All right. So let's just go ahead and evaluate. If you look at series number 1, what type of a series is this? Geometric, right? You see n is only in the exponent. It's an exponential expression. That makes it geometric, right? It's already in the correct form for geometric. We can simply read off that for this problem, A is equal to 2 and R is equal to 3 over 4. So therefore, absolute value of R, which is 3 over 4, is less than 1. This guy is convergent. I'm not going to waste time to determine exactly what it converges to, even though I can. All I need to know is that it is convergent. This is correct. So I'm going to circle that. This is a correct statement. All right, let's look at statement number 2. The sum of negative 1 to the power n times 3n squared over 5n squared plus 1 converges. All right. Which test would you like to use here? Alternating series test. So the problem with the alternating series test, it's not a problem. We could use the alternating series test. All right, let's use the alternating series test. We need to check 2 things. So we need to check this piece right here. This is my sequence part, right? B sub n. We need to check number 1, that B sub n, so the 3n squared over 5n squared plus 1. We need to check to see that that is a decreasing sequence. So when you graph that, let's quickly graph it on our calculators. Let's make sure. And you can just graph it as a function. So when I graph that, it is not a strictly decreasing, but it doesn't really increase either. So it's really kind of hard to tell, actually. Well, it kind of looks like this. It increases for a little bit, and then it increases some more, and then at some point it levels off. So I'm not able to say that it passes, right? But here's the one that we want to look at, number 2. What is the limit as n goes to infinity of 3n squared over 5n squared plus 1? This limit is equal to 3 over 5. It is not equal to 0. So this is the property that we really want to show that fails, this guy right here. Because if this fails, then we can say that this series will diverge, not by the alternating series test, but by the divergence test. So this guy is incorrect. I don't agree with the statement in number 2. All right, let's look at number 3. We have the sum of sine squared of n divided by n to the power 5, and it says that it diverges. So how would you approach this series? I would approach it with a comparison to a p-series. We know the following about sine squared of n. Well, we know the following about sine of n. Sine of n will always be between what two values? -1 and 1. So if you square those values, all right, so sine squared of n will then always be between 0 and 1. So we know this about sine squared of n. So we can then say that the sum of sine squared of n over n to the power 5, if we compare this to the sum of 1 over n to the power 5, we can actually then determine an inequality. Inequality looks like this. So we know that this piece right here, this is a convergent p-series, right? So then the direct comparison test says, because this is a series that is an expression that is larger than the original, by the direct comparison test, my original series will also converge. So this guy converges by the direct comparison test. All right, so this statement is also incorrect. It is a convergent, not a divergent series. So the answer here is going to be answer A, 1 only. The only correct statement is statement number 1. Yes?
So for the second portion, ignore the alternating part?
You don't have to ignore the alternating part. When you take the limit with or without the alternating component, if it diverges, so if you have a sequence that diverges, it blows up. So if you now go ahead and put an alternating component on it, if you have let's say you have a divergence, so if you graph it, it's going to look like that, right? So if you now put an alternating component on that, what is it going to do? It's going to do this. Does that converge? Definitely not. Yeah. It's not going to alternate between negative and positive 3/5. It's gonna probably blow up. Eventually, yeah, eventually it will alternate between those two. Okay. All right. All right, problem number 13. We have a repeating decimal. It says, since the repeating decimal 0.727272 can be represented as the geometric series 72 over 100 plus 72 over 100 squared plus 72 over 100 cubed, etc. The value of this repeating decimal is. All right, so I'm going to do this problem two ways. I'm going to do this problem the way that the writer of the exam intended for you to do this. And the way that they wanted you to do this is to write it as a geometric series. So we could write this as the sum as n goes from 1 to infinity of 72 over 100 to the power n. And then we would then write it, we would probably write it then as, let's see, we would need to pull out one of the 100s. So we could write it as the sum. Since my summation starts at 1, we could write this as 1 over 100 to the power n minus 1. So this is now a proper geometric, right? It kind of fits that mold for the geometric very nicely. So the R value here is equal to 1 over 100, which is less than 1. So that tells me that this guy is going to converge. What is it going to converge to? It's going to converge to A over 1 minus R. So for this problem, the A value is 72 over 100 divided by 1 minus 1 over 100. Again, you don't have a calculator with you, so computing this by hand, 72 over 100 divided by, so 1 is the same thing as, so we have 100 over 100 minus 1 over 100. That gives 99 over 100. Flip and multiply. So this will be 72 over 100 times 100 over 99. When the 100s cancel out, I get 72 over 99. So the answer here is C. All right. So this was the theoretically correct way to do this problem. What is the other way we could have approached this? What do you all know about repeating decimals? Let me give you an example. What can we write 0.3333 as? You could write it as 1/3, or actually 3 over 9. So if you had a repeating decimal 0.7777, you would write it as 7 over 9, right? Did you all know that? What if you had a repeating decimal, but you had two repeating digits? 0. I don't know, let's say 343434. How do we write a repeating that has two digits that repeat? You're going to take the repeating value and put it over 99, right? Or if you had 0.123, if you have three digits repeating, what do you think you're going to do? 123 over 999, right? It's kind of like the easy sleazy way to do this. So if you look at it, if you know that, how would you write this repeating decimal? 72 over 99. You see, it's the same answer that I got. It just took me a fraction of the time. Okay. All right. Y'all good? Okay. Number 14, we would like to evaluate the integral from 3 to 6 of 2 over x minus 3 dx. So this is an improper integral. Do you see that I am not able to plug this bottom bound back into this denominator, right? So this is an improper integral. So I want to write this as the limit, and you can choose any letter that you like. I'm going to say A. The limit as A approaches 3 of the integral going from A to 6 of 2 over x minus 3 dx. All right. Let's forget about the bounds for a second. Let's just focus on the integral. So if we were just to integrate, I would need to do u substitution here. I would let u be equal to x minus 3, which means du is just equal to dx. So that's going to make this integral the integral of 2 over u du, which is equal to 2 times the natural log of the absolute value of u. And when I plug back in, this will be 2 times the natural log of absolute value of x minus 3. All right, so kind of keep this. Just keep this over here for a second and return to our problem. So our problem then is going to be, we're looking for the limit as a approaches 3 of 2 times natural log of the absolute value of x minus 3. And we are evaluating from a to 6. All right, so fundamental theorem says we need to plug in top minus plug in bottom. So this is going to be the limit as a approaches 3 of 2 times, I'll leave that out there. All right, if I plug in the top, I will have natural log of 6 minus 3 minus plug in the bottom will be the natural log of a minus 3. And let's evaluate. This is going to give 2 times over here the natural log of 3. What happens if we plug in 3? And again, we should have at the beginning of the problem put a direction on our limit, especially when you work with logarithms. If you're somewhere on the interval between 3 and 6 and you're approaching 3, you are approaching from the right-hand side, right? So we know we're approaching from the right-hand side. So we can put this direction on this limit. So as we're approaching 3, so 3 is a bigger number that's getting smaller. So what happens to a minus 3? It is approaching 0, right? So what happens to a natural log as its variable approaches 0? Goes to negative infinity, right? Again, if you forget, graph it for yourself. What does the graph of a natural log look like? If we graph natural log, it looks like this. You see, so this is 1. So as we're approaching 0, right, as we're approaching the 0 value, you see the function value dips down to negative infinity, right? So back to my problem here. So what we have is a minus and a minus, so plus infinity. Anytime we're dealing with an infinity, this is just going to be infinity, right? So I'm going to say that this guy will diverge to positive infinity. Answer here will be D. All right, what did you guys think of part 1? It took me about 40 minutes, but I went through it in great detail, right? If you were doing this on your own shorthand, you could probably do it in 2/3 of the time, right? You should be able to. All right. Was there any problem on here that you feel was like unfair, out of place? We never learned this, didn't know how to start the problem. You see, you knew how to do all of these, right? So this is what you're going to be facing on your exam tomorrow. It's things that you know. All right, part 2. So at this point, you have your calculator, and what you're going to notice is you're not going to use it very much anyway. I did hear this rumor about a very entrepreneurial student who has written a program and is selling it for $10 a pop to poor unsuspecting Calc 1 students, where the claim is the programs will help you to solve problems on the final exam. I guarantee you it won't. All right, save your $10, study an extra hour, you'll do way better. All right. Okay. So this problem provides us with 3 tables, and we have to make a decision which one to use in order to solve the integral of 1 over 2x times the square root of 36 minus 16x squared dx. All right, so we want to identify this problem right here. What I see is a variable here. So this is going to be a u term. This guy is going to be a constant, is typically an a term. And again, this contains a x squared. So this is going to be a u squared term, right? So I'm looking for a table that has 1 over u and then times the square root of, it looks like a or a squared minus u squared. So it looks to me like the table that I am going to want to use is going to be 2. The problem here is if we decide what u is, over here, u is equal to 2x. But over here, u squared is equal to 16x squared, which makes u equal to 4x. So our constants are currently not lining up very nicely. So the first thing we need to do is get our constants to line up, all right? We can do one of two things. We can either try to change this constant right here. We can try to adjust this constant, or we can try to adjust that constant. Which one is easier to adjust? It's definitely easier to adjust this guy. Let me just make, it's definitely easier to adjust this guy, right? So what I want to do is, if this could be 4x, that would be really, really helpful. So what I'm going to do is I'm going to multiply, get rid of all of this. I'm going to multiply this entire expression by, I'm going to multiply by 2 over 2, right? And what that is going to do for me is it's going to turn this into, I'm going to get 2 over 4x times the square root of, and this 36, I'm going to write that as 6 squared, and then the 16x squared we could write as 4x squared, and here's my dx. So now you see that my terms that I intend to let equal to u or u squared, they now match. So this is going to make things a whole lot easier. It did introduce an additional coefficient to the numerator, but that's fine. Coefficients hold over. Now, when you use a table formula, you have to remember to do proper u substitution. So I'm going to write down here my u in my problem. Let's write this. So u squared is equal to 16x squared. Let me just write this properly. This will drive me nuts. So u is equal to 4x. So we have to find the differential. That makes du equal to 4 times dx. Or in other words, 1 over 4 du is equal to dx. Also in this problem, I'm going to let a be equal to 6. Or of course, a squared is equal to 36, however you want to view that. So when we do the proper substitution, if we substitute all of these values into my problem, what we're going to end up with is, let's see, the integral of, so I already have a 2 up here. The 4x becomes u. Then we have the square root of a squared minus u squared. And then finally, when I replace the dx, the dx is going to get replaced with 1 over 4 du. So 1 over 4 du. I am going to clean this up just a little bit. If the 2 comes out, that makes this 1/2 times the integral of 1 over u times the square root of a squared minus u squared du. All right, so now we're ready. Our table is going to help us integrate this piece right here. The table is going to show us what to put there. So we have this extra coefficient that we just need to take care of. So I have 1/2 times, and I'm going to have to zoom out a little bit here so you can see what my table says. All right, it's this guy right here. It's going to be -1 over a. So that's going to be -1 over 6 times natural log of the absolute value. And then we have a fraction. We have a plus, so that would be 6 plus square root of a squared minus u squared. So that's going to be square root of a squared minus u squared. That's 36 minus 16x squared. All over u, and u is equal to 4x. All right, close that, close bracket, plus c. The only little bit of cleaning up that can really happen here is going to be the 2 and the -1 over 6 is going to become -1 over 12. Nothing else really cleans up. So this will just be 6 plus the square root of 36 minus 16x squared over 4x plus c. Answer here is answer D. All right, any questions? Good. All right. Problem number 2 says, find the area of the region bound by the curves y equals x squared and y equals x plus 2. Let's start by graphing that. All right, y equals x squared is just a parabola. Looks like that. And y equals x plus 2 is a straight line over here. All right. So the first thing that I need to find are these bounds right here. I need to find the x values for these bounds. And I'm going to do that by setting these two functions equal to each other. So where is x squared equal to x plus 2? Well, I'm going to move everything over to the left-hand side of my equation. X squared minus x minus 2 is equal to 0. Because that's going to allow me to solve. This is a quadratic equation that will factor very nicely into x plus 1, x minus 2. And so when I set each one of these factors equal to 0, I get x is equal to -1 or x is equal to 2. So right here, this bound is -1 and this bound is 2. And this is the area that we're looking to find. All right, so we know that the area of a region captured by two graphs in this orientation is going to be the integral of top minus bottom dx. So that's going to be the integral from -1 to 2 of the line that's on top is the x plus 2 minus the guy on the bottom is the x squared. Now, at this point, you are on part 2 of the exam, so you can use your calculator to evaluate this. In fact, you should use your calculator, but just because this is a teachable moment, I will go ahead and evaluate it. So here we will get x squared over 2 plus 2x minus x cubed over 3, evaluated from -1 to 2. Plug in top minus plug in bottom is going to give, let's see, 2 squared over 2 plus 2 times 2 minus 2 cubed over 3. Plug in top minus plug in bottom. -1 squared over 2 plus 2 times -1 minus -1 cubed over 3. All right, at some point, you're going to have to use your calculator. I will do that right here. When I evaluate, I get 9/2. And this would be whatever units squared. Remember, it is an area. And so I get answer E. All right, everybody good? Okay. Problem number 3 says, find the average value of the function f of x equals 3x squared plus 1 on the interval from 0 to 3. You should know the average value formula. The average value formula says that the average value of a formula on an interval AB is going to be 1 over b minus a times the integral from a to b of that function. All right. So for our problem, this will be 1 over 3 minus 0 times the integral from 0 to 3 of 3x squared plus 1 dx. Again, if you know the formula at this point, really is calculator work, right? I'm going to go ahead and write out just a little bit of what we're doing. So this would be 1/3 times when I integrate 3x squared. So that would be 3x cubed over 3. So this will be x cubed plus x evaluated from 0 to 3, plug in top minus plug in bottom. So this would be 3 cubed plus 3. Plug in bottom, of course, is 0. And when I evaluate here, I get, this is equal to 1/3 times 30. Which is equal to 10. So answer A. All right, problem number 4 provides you with a table of values and wants you to use the trapezoidal rule with 5 subintervals of equal width to approximate the integral value from 0 to 10. And the word here is just approximate. So we're going to use trapezoidal rule. Something that you may want to keep in mind here is when you graph this, when you graph the number line, we will have, let's see, let me see if I can get this like, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just doing this so we can just really clearly see our partition points. Our delta x, remember delta x is b minus a over n. So for this problem, it's going to be 10 minus 0 over 5. So it's going to be equal to 2. So our partition points that we want to use are going to be 0, 2, 4, 6, 8, and 10. All right. Those are our partition points. All right, so the trapezoidal rule, just in general, T sub n, trapezoidal rule is delta x over 2 times the function evaluated at the very left-hand endpoint A, plus 2 times f of x sub 1, plus 2 times f of x sub 2, plus all the way up to 2 times f of x sub n minus 1, plus f of b. That's just the formula. So let's plug in there. So T sub 5 is going to be equal to delta x over 2. So that's going to be 2 over 2. All right, and it's going to be my function evaluated at the very left-hand endpoint. So it's going to be f of 0 plus 2 times f of 2 plus 2 times f of 4 plus 2 times f of 6 plus 2 times f of 8 plus f of 10. All right, so this is 1 times. All right, what are those values? All right, so f of 0 is -1 plus 2 times f of 2 is equal to 3 plus 2 times f of 4 is -7 plus 2 times f of 6 is equal to 6 plus 2 times f of 8 is equal to -1 and then plus f of 10, which is just equal to 8. All right, again, you definitely do need a calculator for this. Double check yourself. I get a value of 9. Answer B. Yes.
For Simpson from Trapezoid, there should be
For trapezoidal, there can be odd or even. For Simpsons, there has to be an even number of not terms, but partitions. Okay. All right, everybody good? All right, problem number 5 says, given that the total mass is 32 over 3 rho, calculate the y coordinate of the centroid, that is the center of mass, of the region bound by the graphs of y equals 4x minus x squared and y equals 0 between x equals 0 and x equals 4. So it always helps out if you can graph the region. In this case, when you graph the region, you will see that it is kind of like the top piece of a parabola. It does pass through at 0 and 4. So this is our region. All right. All right, so we are asked to find y bar, which I know is the moment about x divided by the mass. All right, so these are two things that I need to go find. All right, so number one, we've already found the mass is given. The mass was provided in the problem. This is 32/3 times rho. So the second thing that I need to find is the moment about x. Now, the formula for moment about x is rho over 2 times the integral from a to b of your function. If you have more than one function, it's going to be f of x squared minus g of x squared dx. In this case, we only have the one function, so this is going to be rho over 2 times the integral from 0 to 4. And our function here is 4x minus x squared. Our inside function is just the x-axis, so it is the line y equals 0. All right. All right, so I would recommend that you use your calculator to evaluate here. When I evaluate, I get, let's see, 256/15 rho. And so then we're finally able to calculate that y bar. So y bar is equal to the moment about x. So that would be 256 divided by 15 rho over the mass, which is 32/3 times rho. All right. As you can see, the rows are going to cancel out. We don't need to know what rho is. And we're going to evaluate our fractions. I get that this is equal to 8/5, or approximately 1.6. Actually, it's exactly 1.6. I like to write down for myself what it is as a decimal so that I can go back to my problem and plot that back on that graph to make sure that I'm happy with where that value is. Yes.
The rho over 2, you're not subbing in the mass.
What do you mean? Can you clarify what you mean by subbing in the mass?
I realize now, but I'm seeing mass is 32/3 rho.
Mhm.
So I was thinking we could plug in 32/3 rho into the rho over 2. So that's just 1/2 times rho.
No, the rho is just representative of the density of the object. It's not a variable. It's not a variable that can be replaced. Does that make sense? Okay. Any other questions? Okay. All right, problem number 6. Which of the following is the length of the curve y equals 1/2 cosine of x over the interval 0 to pi thirds? All right, so this problem is all about arc length. And so just to get us started, let's write down the formula for arc length. So you will need to know this. The formula for arc length is the integral of the square root of 1 plus the derivative of our function squared dx. And we again evaluate on the given interval a to b. All right. So for my problem, since y or f of x is equal to 1/2 cosine of x, y prime is equal to the derivative of cosine, of course, is negative sine of x. So if we square this, I will get positive 1/4 sine squared of x. So plugging it into our formula, the arc length is equal to the integral from 0 to pi thirds square root of 1 plus 1 over 4 sine, not 4, I'm writing too fast, sine squared of x. Right. You will definitely need your calculator to evaluate this one. When you evaluate, make extra sure that your calculator is set to radian mode when you go take that exam, okay? So this guy I get is equal to 1.084. Answer here is E. All right, problem number 7 says, which of the following series converges conditionally, but not absolutely? So let's just quickly take a look at each one of these and see if we can really quickly say what each one of these will do. For A, right, for A, if you take the alternating component away, does this guy converge or diverge? If you take the alternating component away and we just look at the sum of 1 over n cubed, this is a convergent P series, right? So that means if you give his alternating component back, you have absolute convergence, right? That's by definition. So this guy is absolutely convergent. All right, so done. So that's not it. How about B? The sum of -1 to the power n divided by 3n. If we use the alternating series test and we check two things. Number one, is 1 over 3n, is this a decreasing sequence? Definitely is. Number two, if we check the limit as n goes to infinity of 1 over 3n, this limit goes to 0. Check. So this guy is convergent by the alternating series test. So now we need to figure out, is this convergence absolute or conditional? So what we have to do is take his alternating component away. So what does the sum of 1 over 3n do? If I take his alternating component away, does he still converge? No, this is a divergent harmonic. Remember, the sum of 1 over n is a divergent harmonic. The 1/3 is just a coefficient. So as soon as you take his alternating component away, he no longer converges, which says that he relies on that. It's conditionally convergent. So this is it. B is it. Let's quickly see if we can really fast eliminate the others. C, what will this series do? What does the divergence test say about this guy? If we just take the limit as n goes to infinity of 2n squared plus n plus 1 over 5n squared plus 2, this limit goes to 2 over 5. It does not go to 0. So this guy will diverge by the divergence test. How about D? We have the sum -1 to the power n minus 1 times 2 over 5 to the power n. I tell you what, take the alternating component away and see if he still converges, right? So if you look at the sum in going from 1 to infinity of 2 over 5 to the power n, we could write this as the sum of 2 over 5 times 2 over 5 to the power n minus 1. This is a convergent geometric, right? And he converges without the alternating component. So with the alternating component, he is absolutely convergent, right? Absolutely convergent. What about E? The sum of -1 to the power n over n factorial. Anytime you have factorials in the denominator, you're always looking at convergence, guys. All right, factorials in the denominator says it's going to converge. Again, here you could use the ratio test, or you could, if you want to do it a little bit quicker, the alternating series test. 1 over n factorial. Is this a decreasing sequence? Yes. What is the limit as n goes to infinity of 1 over n factorial? equal to 0. This guy diverges by the divergence test. Right, so the only one that works here, the only one that converges but conditionally is answer B. All right, number 8. We would like to find the values for x for which the power series converges. So we're looking for an interval of convergence. For this problem right here, I'm definitely going to have to use a ratio test because I see n part of the base number and the exponent, so I can't use geometric. I also see factorials. That usually tells you to use ratio test. So we're going to set this up. We're going to assume convergence. So if that is the case, the limit as n goes to infinity of a sub n plus 1 over a sub n must be less than 1, right? So if I set that up, I will have x minus 3 to the power n plus 1 divided by 5 to the power n plus 1 times n plus 1 factorial. All of that over x minus 3 to the power n over 5 to the power n times n factorial. And this is an absolute value. All right. So I'm going to flip and multiply. So I'm taking the limit as n goes to infinity. So I will have x minus 3 to the power n plus 1. As I flip, I'm going to kind of just rearrange so I get like terms together. So here I will have x minus 3 to the n, 5 to the n, and n factorial. This is still absolute value. All right, what cancels out here? All right, so the x minus 3 terms, there's one more in the top than in the bottom, so this is going to cancel. With the 5s, there's one more in the bottom than in the top, so this is going to cancel. And then what happens to n factorial over n plus 1 factorial? There's just an n plus 1 on the bottom. So what I get here is the limit as n goes to infinity. So I get x minus 3 divided by 5. And then we also have a n plus 1 in the bottom. All right, so look at this limit. If we plug in infinity for n, where does this limit go? Limit goes to 1 over infinity, which is equal to 0. Can you think of any value that you can plug in for x that would keep this limit from going to 0? Does not matter what you plug in for x, I can plug in a bigger value for n, right? So this limit always goes to 0, regardless of what x is. So in other words, x can be anything and the limit is still 0. So we always have convergence. So in other words, any value for x will work here, right? So there's no restriction. So we can say all x, or we can say x is on the interval from negative to positive infinity. Answer E. All right, so there was no restrictions here. All right, number 9. We would like to find a power series representation for f of x equals 2x squared over 2 minus x. All right, this looks a little crummy. I know what I want for it to look like. It almost looks like a over 1 minus r, but not quite. I'm not quite there yet. What can I do to get this guy to fit that form exactly of a over 1 minus r? This thing right here in the bottom left corner really needs to be a 1, right? So what I'm going to do is I'm going to multiply both the top and the bottom by 1/2. So I'm just multiplying by 1/2 over 1/2. So what that gives me is x squared over 1 minus x over 2. So now it fits that form, right? So this is cool. This is going to be my a. This is going to be my r. It now has that form of a over 1 minus r. So we can now write it as, and let me quickly remind you guys, if we have convergence, let me just quickly, let's write the formula down here. If we have convergence, if we have a over 1 minus r, then this would be equal to the sum as n goes from 0 to infinity of A times R to the power N. So this is the formula that we're using. So we're going to have our function f of x here is going to be the sum as n goes from 0 to infinity of A, which is x squared, times R, which is x over 2 raised to the power n. Now, here's the thing. I'm happy with this answer, but it may not match any of the answers in the list. Surely, I'm looking at it right now, it doesn't. It does not match anything in there. So let's clean up a little bit. We could write this as the sum of, all right, so we have x squared. If we distribute this power, the outside of the parentheses, we could write this as x to the power n over 2 to the power n. And then what we can do is we can just combine those two guys back together. And so what that would give me is the sum in going from 0 to infinity of x to the power, let's see, n plus 2 divided by 2 to the power n. Now, if I write it like that, I do have an answer that matches. Answer D. All right. Number 10. All right, so this problem says that a cable that weighs 5 pounds per foot is 30 feet long and hangs from the top of a tall building that is 100 feet tall. How much work is done in pulling the cable to the top of the building? All right, so here's the thing. You've got 30 feet of cable hanging over the side of the building. Doesn't matter how tall the building is. Does it matter whether the building is 50 feet tall or 100 feet tall? It doesn't matter. So you can set it up for like that, or you can simply set it up as here's a building that is 30 feet tall. And so here's a piece of rope that hangs over the side that is 30 feet long, right? It just hangs all the way to the ground. I don't see there's no mass or anything at the bottom. There's no bucket or solid weight. So the very simple way that we're going to set this up is simply going to be the integral of, it weighs 5 pounds per foot, all right? So 5 pounds per foot, and there is 30 minus y feet of it. Remember, as you're pulling the cable, it keeps getting shorter. So we have to give a function for the length of the cable. That function is 30 minus y, all right? dy, and I will integrate from 0 to 30, right? And so when I actually evaluate, again, you may use your calculator, I get 2,250, and this will be measured in foot-pounds. Answer B. If you had set this up as the 100 feet tall building, so you would just have 30 feet of rope hanging down. So this would be 100 feet, and then this would be 70 feet. So if you set it up like that, it would be the integral of 5 times 100 minus y dy, and then we would integrate from 70 to 100. And you will see that that is going to give you the exact same value, right? I think it's just easier setting it up this way, okay? All right, number 11. All right. Here's an easy one. Give the Maclaurin series expansion of f of x equals arctangent of x. This is one of the 5 series that you have memorized. You should not have to derive this. You should be able to look at this and go, well, A is the answer, right? It is one of your 5 common series that we will use so often that this is kind of a freebie question right here, right? Number 12. All right, suppose 30 foot-pounds of work is required to stretch a spring from its natural length of 12 inches to a length of 24 inches. What is the spring constant K? All right, so here's what's going on. So here's your spring. And it has some natural length, but it has some length. It says it has a natural length, so let's call this 0. So here's 12 inches. And we're going to stretch it to a length of 24 inches. So I'm going to convert this. I don't want to work with 12 inches. It's not how far it has been stretched. That is the natural length. So the first conversion I make is for natural length. So we're going to call this 0 inches and 12 inches. And then I'm going to make another conversion. I don't want to be working in inches. I need to be working in feet. So this is 0 feet. This is 1 foot. And so these are the only values. This bottom row, after you've converted for both natural length and units, this is the row that you want to use. All right, so it says that 30 foot-pounds of work is required. So remember that work is equal to the integral from A to B, stretching it from and to kx dx, right? Formula for work. So we know that 30 foot-pounds of work is needed to stretch this thing from 0 to 1 of kx dx. Our job is to find k. So if I actually integrate here, integral of kx is going to be kx squared over 2. We want to evaluate from 0 to 1, right? So this is going to be k over 2, plug in top minus plug in bottom. So 1 squared minus 0 squared. So I simply get that 30 is equal to k over 2, which means k is equal to 60. And the unit that we use is pounds per foot for our k value. Answer here is C. All right, questions. So we're done with part 2. We're still doing very good on time. Questions for me so far? All right, let's go. Let's do this last part, part 3. All right, and again, for part 3, I want to emphasize, make sure that your name, so before you start, make sure that your name, there's a name box on each page. Make sure that your name is on every single page. If your name is not on a page, we don't have to grade it, okay? Keep that in mind. All right, part 1, problem number 1 says, evaluate each integral. You must show all your work to receive credit. All right, so for this first one, this to me looks like a standard U substitution problem. We just want to see if you can kind of just follow the steps and show all of your work. Show all of your work means good notation. Don't leave off a dx when you find a differential. Show your work neatly organized so that we can follow it and give you the maximum amount of credit, okay? So for this problem, I will let u be equal to 10 minus x to the power 4. That makes du equal to minus 4x cubed dx. Don't forget that notation, right? I do have a 5x cubed. That's going to make it kind of hard. So I tell you what, let's just take that negative 4 to the other side. So negative 1 over 4 du is equal to x cubed dx. All right, here we go. Let's substitute. So I'm going to have the integral of 5 times the square root of u. So the x cubed dx is going to get replaced by a negative 1 over 4 du. Looks kind of sloppy, but that's kind of what it looks like when I do that replacement. You can write it a little bit neater if you want to. This is negative 5 over 4 times the integral of u to the power 1/2 du. Right? Show each step. Do not skip steps. All right, so let's actually go ahead and integrate. So this is negative 5 over 4 times. All right, add 1 over add 1. If I add 1 to 1/2, it's equal to 3/2. You can either divide by 3/2 or immediately multiply by 2/3. All right, and I'm going to clean this up a little bit. So let's see, I get 10 over 12, which is going to simplify, and it's just going to be 5 over 6, right? So negative 5 over 6 u to the power 3/2. All right, now let's plug back in. Negative 5 over 6, u is equal to 10 minus x to the power 4 raised to the power 3/2. And when you report your final answer, so this is minus 5 over 6, 10 minus x to the power 4 raised to the power 3/2. Do not forget that plus C on your final answer. You don't have to carry the plus C throughout your work. As long as it's on your final answer, we're good to go. Okay. Questions? Not hard, right? This is not very challenging yet. Let's see if it gets harder. I don't think it does. All right, part B, we have the integral of x to the power 5 times natural log of x dx. All right, this is a textbook integration by parts problem. It is a product between two different families. So remember the Liat principle, L-I-A-T-E. We have an algebraic expression and we have a logarithmic expression. Whichever one is higher up on the list is more likely to be u. So for u, I'm going to choose natural log of x. Oops, not dx. The dx goes with the dv. dv in my problem is x to the power 5 dx. So there's my u and my dv, right? So I chose. All right, so what is du? du is 1 over x dx. Again, do not forget your dx. v will be equal to x to the power 6 over 6. All right, so the formula says the integral of u dv is going to be equal to u v minus the integral of v du. So this is going to be natural log of x times 1 over 6x to the power 6 minus the integral of v, so 1 over 6x to the power 6 times du. du is 1 over x dx. I definitely need to clean up before I do my next step. All right, so I can factor out, first of all, the 1 over 6 will factor out. X to the power 6 times 1 over x is going to be x to the power 5. All right, so now I'm ready to finish it up. Natural log of x times 1 over 6x to the power 6 minus 1 over 6 times. The integral of x to the power 5 is 1 over 6x to the power 6. I'm going to clean up one more time. Natural log of x times 1 over 6x to the power 6 minus 1 over 36 x to the power 6 plus c. Let's make sure we get this answer into our answer box. Oops. I don't know what I was doing here. So this is natural log of x times 1 over 6x to the power 6 minus 1 over 36 x to the power 6 plus c. All right, any questions for me? We know that you know how to do many of these steps in your head. The objective of the free response part is for you to show us how it is done, right? So show each and every step. All right. Problem C, the integral of 11x minus 6 divided by x squared plus 3x minus 18. How do you think we're going to handle this problem? Partial fractions. This is a textbook partial fractions. So let's just do that first. I'm going to go ahead here and take the 11x minus 6 divided by x squared plus 3x minus 18. All right. So 11x minus 6. This factors very nicely into x plus 6, x minus 3. So I want to write this as a over x plus 6 plus b over x minus 3. Now, if I cross multiply again, I'm going to get a times x minus 3 plus b times x plus 6 over x plus 6 times x minus 3. So this gives 11x minus 6 is equal to a times x minus 3 plus b times x plus 6. All right, so that equation is going to allow me to solve for a and b. All right. I need to choose some values for x where I'm going to fix this function at that's going to allow me to solve for a and b. Now I get to choose any values of x that suits me. What would you like to plug in? 3 and -6. Those are called the annihilators. You don't have to use those. You can use 0 and 1, but if you use the annihilators, it's just going to make the calculation so much easier. So I'm going to say let x be equal to -6. Right, if x is equal to -6, 11 times -6 is -66 minus 6 is -72. -6 times -3, so I get -9a plus 0 times b. All right, so this, if I divide both sides by -9, gives me a is equal to 8. I'm also going to follow you guys' advice. I'm going to let x be equal to 3 and do this again. So 11 times 3 is 33 minus 6. So that's equal to 27. 3 minus 3 is 0a. 3 plus 6 is 9b. So here I get that b, if I divide both sides by 9, b is equal to 3. So what I was able to show here is that this integral becomes the integral of 8 over x plus 6 plus 3 over x minus 3 dx. All right, so now we can go ahead and integrate. So I get 8 times natural log of absolute value x plus 6 plus 3 times the natural log of the absolute value of x minus 3 plus c. Let me put that in the box. 8 times the natural log of x plus 6 plus 3 times the natural log of x minus 3 plus c. All right, questions? All right, are we good? All right. All right, problem number 2 says, consider the finite region R bound by the graphs y equals x cubed minus 2x plus 4, x equal to 2, x equal to -2, and y equal to 0. In part A, we want to start by sketching and calculating the area of this region. All right, so here we go. Doesn't have to be a professional graph. Just do your best to show that you can see more or less. Cut it off here is 2 and -2. All right, so here's this region. All right, again, if we're looking for area, remember, area is going to be the integral of top minus bottom in this orientation. All right, so here it's going to be the integral of x cubed minus 2x plus 4. The bottom is just the line y equals 0, so I'm not going to include that, but my bounds go from negative to positive 2. So there are my bounds. All right, calculate the integral by hand, showing each step. All right, there you have it. They want to see if we can integrate too. Here we go. I'm gonna not leave out any single step. So this is x to the power 4 over 4 minus 2x squared over 2 is just x squared plus 4x. And I'm evaluating from -2 to 2. All right, so plug in top minus plug in bottom. All right, if I plug in the top, I'm going to get 1 over 4 times 2 to the power 4 minus 2 times 2 squared plus 4 times 2. All right, plug in top minus plug in bottom. Let's see if I can fit it in. 1 over 4 times -2 to the power 4 minus -2 squared plus 4 times -2. All right. Once you've shown this much, you can definitely use your calculator. I think that this qualifies as showing your work. At this point, put it on your calculator. I get 8 minus -8, so I get a value here of 16. And if you want to, go ahead and put in units square, just to show that you understand that you just calculated an area. Yes?
So we're gonna be told that, to calculate the integral like that?
You may. I don't know what the test is, what the exam looks like. They could say just set up the integral, or they could say set up the integral and evaluate it with your calculator. In this case, they said set up the integral and evaluate it by hand.
But they'll like.
Just follow whatever instructions they give, okay? All right. Part B of this problem, the region R does not change, but this time we're just going to rotate it about the x-axis. Sketch the three-dimensional solid and set up the integral. See, in this case, they just want you to set up the integral and not even evaluate it. All right, but we do want you to sketch not only the region, but the solid that is formed. We want to see if you can visualize three-dimensionally what this is going to look like. So if we take that graph, remember, this is what it looked like. It doesn't have to be pretty, but if you take this graph and you were to rotate it about the x-axis, it's going to look something like this. See? So this is what we want to see, is it rotated properly? All right, what are we going to use, disc washer method or shell method? Disc washer would be the right method to use here. So it is going to be pi times the integral from -2 to 2. Those bounds were given. All right, so, I said disc washer, but it's really disc. It's not washer. This thing is solid because there's not a second function. There's just the one function that got rotated, right? So it is just going to be that function. It is the x cubed minus 2x plus 4. And this guy would need to be squared, dx. And that's it. All you want to do is just set up that integral. Done. So there's really no other work here. All right, in part C, the region R is rotated by the line x equals -3. Sketch the three-dimensional solid and set up the integral. All right, so again, here we go. Let's see if I can draw a straighter line. All right, so it looks like right, so again, this is the original region, right? This is -2 and 2. So here's the line x equal to 3. And then if this is the line x equals 3. So it may not be pretty, but you can see that it's rotated about the line x equal to 3. Something like that, right? Okay, so for any time you're going to rotate like this around the y-axis or something parallel like the y-axis, the way you stir your coffee, right? So think about the potter's wheel versus the wood lathe. So this is the potter's wheel in this direction. You want to use shell method unless the problem specifically tells you to do different. Use the shell method. So for the shell method here, we need to find the point radius. So if you consider an arbitrary shell, so let's say this was an arbitrary shell that got rotated over here. So my arbitrary shell is at some point x, and then we have, so this is arbitrary shell, and then we have the axis of rotation. So mark those two. The point radius is always right minus left. It's the distance between these two lines. It is this distance right here. So it's right minus left. In this case, and I didn't mark this very well, this is the line x equals -3, not x equals 3. All right, so the point radius is going to be x minus -3. So it becomes x plus 3. So I'm going to remind you that the formula for shell method says volume equals 2 pi times the integral of this thing that we call the point radius times top minus bottom dx. So if we set this up, this will be 2 pi times the integral from -2 to 2 of the point radius, x plus 3, and then again, top minus bottom. So that's going to be, there is only a top, x cubed minus 2x plus 4 dx. All right, questions? Yes. You're gonna have to say that a lot louder. Yes, the point radius is the distance. Let me quickly, let me do it over here. So the point radius is the distance between the axis of rotation and an arbitrary shell. So let's say you have a, I don't know, let's draw a coordinate axis. And let's say we have a region, let's do this region right here. And let's say we rotate this region about this line right here. This is the line x equal to 5. So when you rotate it, it looks like this. So the shell method says really what we're doing is we're just considering one little shell, right? We're considering one little shell that has been rotated like this. We're calculating the volume of one shell at a time. So for this particular shell, I would like to know, in this particular shell, I drew it at an arbitrary value of, at an arbitrary point x. The point radius is the distance between the shell and the axis of rotation. So this kind of thicker green line that I'm drawing right here. So the distance between these two are always going to be right minus left. So in this case, the point radius will be 5 minus x. Does that make sense? So it depends on which direction. So if you rotate it to the left of your region, it's going to be different. It's going to be, so if you rotate it from to the left, it's going to be x minus the line. But if you rotate it to the right, it's going to be your axis of rotation minus x, right? So it depends on which direction you rotate. All right, let's look at problem number 3. We have over here the function f of x equals natural log of x cubed. We would like to use Simpson's rule with n equal to 4 subintervals to approximate the integral from 1 to 9 of the natural log of x cubed dx. We want to give the equation that calculates this value and then also evaluate it. All right, I'm going to start by drawing a number line. It's always very helpful to me to have a number line. And my number line is going to go from 1 to 9. If I would like to, let's see, subdivide into 4 equal subintervals. So I will have 1, 3, 5, 7, and 9. There you go. I have 4 subintervals. You got n equal to 4. My delta x value. Remember, delta x is b minus a over n. So in this case, 9 minus 1 over 4. So 8 over 4 is equal to 2. Right? So Simpson's rule says S sub 4 is going to be delta x over 3 times f evaluated at our very left-hand endpoint. So 1 plus 4 times f of 3 plus 2 times f of 5 plus 4 times f of 7 plus f of 9. So remember, let me highlight this. We start with a 4, we end with a 4 as far as those coefficients. So remember that formula. When we are asking you on an exam, though, to give the equation, this is a generic equation, right? I can't plug this in my calculator. I don't know what it is. You have to give the specific equation. So we want to actually see what the function is and what is being plugged in there. So you're going to give the following. Delta x we know is equal to 2. So this is going to be 2 over 3 times All right, what is f of 1? It's going to be the natural log of 1 cubed, right? Plus 4 times the natural log of 3 cubed, plus 2 times the natural log of 5 cubed, plus 4 times the natural log of 7 cubed, plus the natural log of 9. I had to squeeze that in. All right. And then you're going to use your calculator to evaluate. So up over here, I really highly recommend using your Riemann program just to ensure that you're not making a mistake. If you want to double check yourself and just type this in, you can, but do it 2 ways. Make sure you're not typing something incorrectly. Remember, when you're typing this into your calculator program, what is your calculator program going to do with the value for n for Simpsons? It's going to double it. So what do you need to plug in? We need to plug in 2 if you want to get S sub 4. So be very careful of that. I get 35.188380. That's the value that I get. All right. All right, part B says, recall that the error estimate when Simpson's rule is used to approximate an integral from a to b of f of x dx is given by, and we're providing you here with the error bound formula. The error of Simpson's is less than or equal to k times b minus a to the power 5 over 180 times n to the 4th, where k is the absolute maximum value of the 4th derivative on the interval ab. All right, we're going to calculate an error, but first we want to go ahead and find the value for k. All right, so that means we need to start by finding the 4th derivative. All right, so f of x, start with f of x, is equal to the natural log of x cubed. Now, make the derivative a little bit easier for yourself here. Do you all remember the rules of logarithms? What does the power rule say? We can write this as 3 times natural log of x. Doesn't that make the derivative a whole lot easier? All right, so first derivative is equal to 3 times 1 over x. I'm going to write this, usually we want it cleaned up, but in this case, I'm going to write it as 3x to the power negative 1, just because I'm looking to take multiple derivatives. All right, the second derivative is going to be equal to negative 3x to the power negative 2. The third derivative will be 6x to the power negative 3. And then the fourth derivative will be equal to 6 times negative 3 is negative 18 x to the power negative 4. Or if you will, negative 18 over x to the power 4. Now, you got to be really careful when you graph this because you're really supposed to graph the absolute value of this function. So the absolute value is just going to be 18 over x to the power 4. All right, so when I graph this, 18 over x to the power 4, I get a graph that looks like this. And mind you, this is the graph of the absolute value, right? This is the graph of the absolute value. So on the interval from 1 to 9, we really only care about this interval right here. Where does this function reach its maximum value? At 1. And what is that maximum value? That's what I'm looking for. That is my k value. So k is equal to the fourth derivative evaluated at 1, absolute value of this. So it is 18 divided by 1 to the power 4, which means it is equal to 18. So k is equal to 18. Where do most students screw this up? They don't make it as far as the fourth derivative. And you know what? Y'all have passed Calc 1. You can take the fourth derivative. You can do it. Okay? Stop, pause, hesitate, focus. You can do it. Yes. Should what? Can I show you after? All right. The next part of the question then is, okay, so we know this. So use the error bound formula to find K. All right. So remember, error of Simpson's. The formula is given is less than or equal to K times B minus A raised to the power of 5 over 180 n to the power 4. And guys, again, show all your work neatly, precisely. I know that on this exam, if a student missed K, if they got an incorrect value for K, but they performed the steps of part 2 correctly, we followed the error. As long as you showed us if everything else was plugged in correctly, you got some partial credit, right? But you have to show all your work for that, right? And show it neatly so we can follow it. All right, so 18 times B minus A is going to be 9 minus 1 to the power 5 over 180. Remember, n was equal to 4 to the power 4. When I evaluate, I get 64 over 5, which is approximately 12.8 or exactly 12.8. Round your answer to 1 decimal place. 12.8. There you go. Yes.
Are we going to get the error formula on the test?
I don't know. It depends on who the exam author is. You may or may not. You are responsible for it ultimately. So I would make sure that I know it, but they may provide it. I don't know. Okay. All right. Part 3 here says, find the smallest value of n that must be chosen to ensure accuracy to within 0.001 if the Simpson's rule is used to approximate this interval. All right. So now instead of knowing what n is, we know what we want our error to be. How should we choose n? So we're going to have to rewrite our formula. So again, error of Simpson's less than or equal to K times B minus A to the power 5 over 180 n to the power 4. If we solve this equation for n, we're going to see that n must be greater or equal to the 4th root of K times B minus A to the power 5 over 180 times that particular error that is chosen. All right, so again, plug in n is greater or equal to. All right, so this was 18. Again, 9 minus 1 to the power 5, 180 times 0.001. When you're typing this on your calculator, again, type it in at least twice. There's a number of ways you can type this in incorrectly. If you have the newer software on your calculator opens a palette and you can easily see if you typed it in wrong. But especially if you have the older version of the calculator, if you don't put parentheses around the entire denominator, you're going to get an incorrect value. All right. So make sure you practice this a few times so you know how to plug it in. I get a value here of 42.5. So what are we going to report as our answer? How about 44? You have to round it. So n is a natural number, has to be a positive integer. But furthermore, because this is Simpson's rule, n has to be even. So for Simpson's rule, we round it to the next even integer. So in this case, 44. All right. All right. Any questions here? We good? All right. Problem number 4, the old pumping problem. It says that a large tank has the shape of a cylinder on its side and is filled half full with water. The circular cross section of the tank has a diameter of 8 feet and a length of 10 feet. Set up the integral that calculates the amount of work required to pump the water out of the tank to a height of 2 feet above the top of the tank. All right, so what we need to do is determine what a slice of water might look like. So I'm going to go ahead and draw I'm going to put this on a coordinate axis. So I'm going to put a big old circle here on a coordinate axis. And I'm going to set it up so the center of my circle is at the origin. You can set it up differently. So since the diameter is 8 feet, the radius is 4. And so that makes the equation for this circle. So the equation of a circle with radius 4 and center at the point 0, 0 is just going to be x squared plus y squared equals 16. All right, that's it. All right, we're going to come back to that in a second. So if I were to take a slice, let's say I made a slice right here. I'm going to make a slice right here. So you have to kind of think three-dimensionally maybe what this slice is going to end up looking like. Is that more or less? All right, so there's a slice, right? If we pull it out, this is what the slice looks like. So right here, the width of this slice, there's a width and there's a length. So the length doesn't change. If you look at the shape of the tank, the length doesn't change. And the problem says that that length is 10 feet. But what does change is the width right here. So this entire thing right here, this is how wide my tank is. But if this is a point on the edge of the circle, let's call that point XY, then the distance from here to here, this distance right here is X. So what does that make W equal to? W is equal to 2X. So if we come back over here and we want to write the area, write a expression for the area of a slice, right? W times L. So the W is going to be 2X and the length is 10. So that makes it 20X. But this is a function with respect to X. I'm really hoping for a function with respect to Y. So we need to come back here to this equation and figure out how to express X in terms of Y. So if we solve for Y here, Y is equal to the square root of 16 minus X squared. So I can now take this Y right here. I solved it the wrong way. I'm sorry. X is equal to the square root of 16 minus Y squared. That's what I meant to do. All right, I'm going to take this X and I'm going to plug it in for that X right there. So the area function as a function of Y is going to be 20 times the square root of 16 minus Y squared. There it is. That is what I really needed. So I'm going to use the formula here to set up the integral. So I know that the work is equal to the integral from A to B of the area of the slice times the water weight times the distance dy. So what are all of those components? All right. So this will be the integral of the area of the slice we just found. That is 20 times the square root of 16 minus Y squared times. Next up, what is the water weight? I'm going to go back to the top of the problem. So it says that we are filled with just regular water. It's not like hot chocolate or oil or something. So I know the density is 62.5 pounds per foot. That's given in the problem too. So that is my water weight, 62.5. All right, and then the distance, where is it being pumped to? So again, according to my diagram, I have to go back to my diagram. The top of the tank is at a level 4, right? Because the radius of the tank is 4 feet. But we are pumping it to a height 2 feet above the top of the tank. So it doesn't go to 4, it goes to 6. It goes to a Y value of 6. So that height right here is going to be 6 minus Y dy. All right. And then lastly, I need to put bounds on my integral. Where's the water at? So again, go back to your original diagram. Here, the bottom of the tank is at -4. and it says that the tank is half full. So that means that the water is right here, right? This is where the water is at, everything that I'm shading. Maybe I need to shade it a little bit darker. All right, here's where the water is at. Can you see that better now? Okay, that's where the water is at. All right, so the water is between -4 and 0. So that goes on the bounds of my integral. All right, and then lastly, they did ask us to evaluate it. So use your calculator to evaluate. They said calculators were fine. I get 89,498.52, and do not forget units. This will be measured in foot-pounds. All right, questions? All right, last problem. Says consider the Maclaurin series expansion for sine of x. So you're being given the expansion. There it is. This is valid for all real numbers of x, or real values of x. Use the given expansion to find the first 5 terms of the expansion for f of x equals x cubed times sine of x. All right, so here it is. Sine of x is equal to x minus x cubed over 3 factorial plus x to the power 5 over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over 9 factorial, and so on. We are trying to create for ourselves an expansion for x cubed times. So I'm literally just going to multiply both sides of this equation by x cubed. All right, so here we go. This is going to be x times x cubed is x to the power 4. X cubed times x cubed is x to the power 6 over 3 factorial. X to the power 3 plus 5 is 8 over 5 factorial. X to the power 9 over 7 factorial. X to the power 11 over 9 factorial. There's really nothing to clean up. I could have put it straight into the box, but here we go. X to the power 4 minus x to the power 6 over 3 factorial plus x to the power 8 over 5 factorial. X to the power, hold on, 9, hold on, I messed up somewhere. Yes, this is 10, not, yep. I messed up right there, sorry. 7 and 3, so this was 10 and this was 12, right? X to the power 8 over 5, x to the power 10 over 7 factorial, x to the power 12 over 9 factorial. Make sure you got 1, 2, 3, 4, 5. They asked for 5 terms. There it is. All right. Any difficulty adjusting a known power series to get a new power series? All right, let's keep going. They want us to use this to find, use the expansion you found in part A and only the first, this is important, only the first 4 terms to approximate the integral from 0 to 2. All right, here we go. So if I use the first 4 terms, we're going to find the integral from 0 to 2 of x to the power 4 minus x to the power 6 over 3 factorial, x to the power 8 over 5 factorial, x to the power 10 over 7 factorial. They said 4 terms. Use exactly as many terms as they tell you to use. Otherwise, your answer is not going to be the same. All right, here we go. When I integrate, I get x to the power 5 over 5 minus x to the power 7 over 7 times 3 factorial plus x to the power 9 over 9 times 5 factorial minus x to the power 11 over 11 times 7 factorial. And I'm going to evaluate from 0 to 2, right? So plug in top minus plug in bottom. So that's going to be 2 to the power 5 over 5 minus 2 to the power 7 over 7 times 3 factorial plus 2 to the power 9. Show all your steps. I know this seems really redundant, but show all your steps. So plug in top. When you plug in the bottom and each term is going to be 0, you can really just do that. That is okay. We can see that the bottom, when you plug in 0, the whole thing is going to be 0. At this point, plug it in your calculator, and it is equal to 3.7 895 1418 951. Now, what I would do if I were you and I had a little extra time is I would actually just stick that thing on my calculator and see more or less what it is equal to. It should be in the same ballpark as your answer, not exactly the same. And if you put this answer down here, you're not going to get credit, but that tells you whether you kind of did it right? It'll point out if you made a big careless error. All right, pay attention to rounding. We want to round to 6 decimal places. So this answer would be 3.78951. All right. Part C says use the alternating series estimation theorem to find an upper bound for your answer in part B. So in other words, the remainder after 4 terms, we used 4 terms. So what is the difference between the true sum and my partial sum S sub 4? It will be less than or equal to whatever the next term in the sequence would have been, B sub 5. So if I had found that 5th term, what would it have looked like? It would be the integral from 0 to 2. Remember, we had it up here. There it is. There's the 5th term. Just integrate that, right? So that is x to the power 12 divided by 9 factorial. All right. So this is equal to x to the power 13 over 13 times 9 factorial, evaluated from 0 to 2. So that would be 2 times, or 2 raised to the power 13 over 13 times 9 factorial. And I get a value of 0.00173653. And again, round to 6 decimal places, 0.001737. This will have to be 737 when we round properly. All right, questions for me? All right, it took me just over 2 hours to finish this exam. And that is 2 hours while I am writing down everything and providing explanations, right? This is a lot of detail. So I still have an hour left over to ask for a piece of scratch paper and just go over all those things again. Check answers with your calculator. When you're done, before you hand it in, look back over and see, did I put a plus C on every integral? Just look through it as if you're grading yourself. Is there a plus C everywhere where there needs to be a plus C? Did I put a dx every time I found a differential? Look for notation, look for anything that you can improve, look for anything that you can recalculate. All right? All right. 1 second. Thank you.
I'm about that.